Okay, hello everyone, welcome. Thanks for joining the webinar. We're here today to get a guide to graph UX, or my favorite title, how to avoid wrecking your graph visualization. I always enjoy webinars that talk about how to do things badly as well as how to do things well, and very much looking forward to this one. So thanks for joining. I can see we've got a few more people dialing in, so we'll get going in just a second. While I do that, a couple of points. First of all, just to let everybody know, we are recording the webinar and it will be available to you within the next few days. We'll send out a link with that recording. And also to let you know, you should all be muted, but we will be taking questions over the GoToMeeting and we'll answer those later. So the hard work today is going to be done by my two colleagues, Joe and Christian. Both of them are colleagues of mine here at Cambridge Intelligence. My name is Dan Williams. I'm the product manager for KeyLines, but all the talking today will come from Joe and Christian. Joe, you may know from KeyLines support if you've been using it, and Christian, you may know from the sales and technical pre-sales. Both of them are very experienced in graph visualization, and we're looking forward to hearing what they have to say. So this is the plan for the day. We're going to start with, we're going to split the webinar into two parts. So the first part, we're going to talk about the data and the visual models, and the second part, we're going to talk more about interaction. So there's visualization and then there's interactive visualizations, and we want to talk about both aspects to that. That'll take probably around about 35-40 minutes, and then we'll finish up with Q&A. So please do send in your questions. There should be a GoToWebinar panel where you can click the questions button and send questions in for Joe or for Christian, and we'll take those questions as they come at the end. So just by way of quick introduction, I wanted to talk a little bit about why we're here. We're going to be talking a lot about KeyLines. So for those of you who aren't familiar with KeyLines, it's a toolkit for building interactive visualizations of connected data. You can see an example of one on the screen right now. And the reason we're here today really is because with KeyLines, we give you a huge amount of power to do pretty much anything you want with these visualizations. Everything is up to you to control: the way it looks, the colors, the styling, the way it animates, what happens when you click on things, what you allow users to do, how you allow users to interact with the chart, and so on. So we give you a huge amount of power. It's a very flexible toolkit. And if you are trying to build a visualization, an interactive graph data visualization, whether you're using KeyLines or anything else, you have a lot of power. But with that power comes great responsibility. And I've got a couple of horrific screenshots there of graphs that have been done badly for various reasons. I think everyone would probably argue that those are pretty unpleasant visualizations. So great responsibility, yeah, to make sure that what you put in front of your users is a delightful experience. KeyLines is a tool that lets you bring connected data to life. And I've got Frankenstein down there. Frankenstein realized that just because you bring something to life doesn't mean to say you give a delightful user experience with it. And we're going to talk today really about how to handle that responsibility and do a responsible job for your users. So we're going to give you a bit of a crash course in how to avoid the kinds of things we see a lot when we see people trying to build these visualizations, whether it's the way it looks or the way the user interacts with it. So that's pretty much all that I wanted to talk about. I think the first presenter is Christian, so I'm going to hand over to him.
Great, thank you, Dan. So I'm going to be starting off today by talking about the data and the visual models you should bear in mind when thinking about your user experience when creating a graph visualization application. Now, these are kind of the two cornerstones, or the kind of core parts of really starting to come up with how your application will work for your end users. And I've kind of split them into these two categories that I'll just walk you through now. So first up, the data model is really important. It's the foundation of your application. It's all about how the connected data that you want to visualize and present to your end users, how it's built up from different building blocks that I'll be walking you through shortly. The thing about the data model is that small decisions made in the modeling process can really impact your application as you start to build it with KeyLines. So whether it's having too many nodes on the screen or not showing the sort of information that your end users actually care to see, these are all issues that can happen if you decide on a poor model at the start. Now, the data model really feeds directly into the visual model. So what I mean by visual model is the way that that data is presented to the screen. So we're talking about the styling of it, but even just the raw way that it's connected and how that is shown on the screen, that is also the visual model as well. And the reason we're here today is because these two feed directly into the user experience. It does what it says on the tin. You know, the user experience is what your user experiences as they use your application. And I like to think of it as building trust between your users and the application, and in turn, the data that you're presenting inside of your application. You want to provide a visualization or a view of the data in a way that makes sense to your end users and helps them to understand that, you know, the data is realistic, true, and is something they can trust and work with. So in my part today, I'm going to be covering these three questions here. Firstly, how do I model graph data? In turn, I'll then talk about how certain graph data models can be good, so to speak. And then I'll turn over to talking a little bit about what makes a good graph visual model, which sits on top of the data model. So first up, in terms of how do I model graph data, this sort of slide is something you see quite often when we're talking about connected data or graph visualizations or network analysis. These are all the same sort of topic. They're just different words for the same thing. You know, often we start from this slide because it kind of gives you an idea of what we're actually working with here. So nodes shown here on the left and the right, these are sort of real world entities or effectively some sort of event or something that you wish to show as some sort of actual node or blob on the screen. The link in the middle, these are often called edges or relationships. We like the terminology link because it kind of makes sense. You know, we're talking about links between different people or different places or whatever. And then we also have properties in the top right. So this is kind of, to get into the weeds a little bit, you know, I often sit in the property graph world where you're talking about having properties that are either contained inside of links or nodes. In this case, this property is on the node. But I find even if you are more of a semantic person who cares more about the semantic sort of data model of working with graphs, when it comes to the visualization, really all you really care about is having properties on those nodes or those links. So I think that's another building block that you work with when you're doing data modeling. So the real contentious thing here when you're doing your modeling is trying to decide effectively between what should be a link and what should be a node. There's a lot of creativity that you can apply to this sort of modeling exercise. And as a result, I find it really nice to work with a whiteboard or back of a napkin or some scrap paper to really get an idea of what models look good and which look bad, and how they really show off your data to your end users. So I usually actually go towards using KeyLines itself for this sort of modeling exercise. So here's just a quick view of that same node and link. It's a really basic chart here. So we see the node here. So this is one of our building blocks. We have another node here, and they have a link between them as well. So this is just a quick view of how I could model my sort of data sources. Now this is quite abstract. So let's use a real world, I say real world, but real world fake data set here. So this is what I have here. So this is fake transaction data. Each of these rows is a transaction with a credit card, and then the columns represent different things as they kind of show you there. So the real world use case for this would certainly be that as an analyst or an end user, I care about some of the facets of this data source, and I want to understand a bit more about maybe either the account owners, which are just anonymized numbers here, or vendors here, which are the where the transactions are made against. But I also maybe care about the properties contained therein as well, so maybe the amounts or the dollar amounts paid at each of these merchants or vendors. And then the date as well, which is interesting for showing patterns over time. So I have a vague idea of what I want to show to my end users, and let's say my end users care most about the users, so they care about maybe the most people making the most transactions at a particular location. But thinking or reasoning about this data source, you know, I would not be unwise to think that, you know, transactions are a good thing to start with. So transactions make a good node choice. So what that means is each of these rows is effectively a node. You know, there's a transaction ID, which is nice. We can use that as the key. And we're saying, you know, let's build a chart with just transactions because, you know, I think that transactions should be kind of the first class citizens for this data set. So let's have a look at what that looks like in KeyLines with our first model view here. So it's kind of funny. It is just nodes because that's what we've defined. We've defined each of these transactions. And already I've put some nice icons there to make it easier to understand what I'm looking at. It's a credit card. You know, this is maybe questionable because maybe you think a credit card should be a actual credit card rather than a transaction. But there's some improvements that you can make to the labels here to make sure it's clear that these are transactions rather than just actual physical credit cards. So this is all well and good, but you're not getting any sort of insight from this from just putting your data in this form. I think this is pretty much equivalent to just looking at it in a spreadsheet, right? It's nice to show you can have a really basic model, but really we're trying to talk about connected data. So this is kind of a bad model, and if you presented this to an analyst who cares about users, that they're going to just laugh at you. So next up, I'd want to think about how I would have a connected element to this. So going back to my data set here, instead of thinking of just about the transaction, I can maybe think about how I also have vendors here as well. So these vendors represent merchants in the real world. And if I add those to the model, this is what I come up with here. So now I see little clusters of the transactions against each of the merchants. So this is starting to look a lot prettier. I put some extra colors in there as well to just highlight some other details that might be interesting. And we've also resized some of these nodes to match the number of nodes coming off them. If I zoom in and out, you can have a look and I can spot some quick insights, like, for example, Chipotle is relatively popular, but not as popular as Amazon over here. There's lots of different people going to Amazon, but for example, over here, the same person is really going to the Bay there as well. So it's kind of funny. But I mean, again, if I was to put this in front of an analyst and really sanity check this, they would say to me, well, this is all well and good, but it doesn't tell me much more than a table with a column that maybe has a count. It's a nice visual way of looking at it, but really this could be summarized by Amazon 200 or Chipotle 50, for example. So it's a little better, but as a model for looking at this data source, I think it definitely has its limitations. So let's add another entity into the mix, or another node into the mix. I'm thinking people makes sense, right? We care about people, so they should have really been in the model all along. So let's jump to the next view of this. And this is immediately, I guess, a lot more attractive in some ways. You know, this is the sort of organic model that you would really, really hope to find in your data sets. If you have connected data, this is what you want to see. You don't want to be coming up with a data model that actually has just nodes connected to one node and then there's lots of pairs of nodes. It doesn't make any sense. You know, the real world is very connected, and this is kind of what you do want to see when you're prototyping your data sources. So let's just have a look here what I'm actually talking about. So here we have the people, those are represented with those numbers as per the spreadsheet. We have all the transactions as shown as the credit cards. And then we have the merchants like Chipotle over here. So here we can see where people are transacting with Chipotle there. So again, this is a nice organic look at my data source, but I don't think it's that helpful when you really dig into it. And part of the reason for that is that all those transactions are actually, while they're nice to see and the colors make them a bit attractive to see, they're all a little overwhelming. I don't really see there's actually that much value to seeing an actual node for these transactions. And I think that goes back to my point from earlier regarding what you would decide to be a node versus a link. I might care to see all those transactions, and I can use the KeyLines reveal function here to look at those in more detail. But really, I think this is cluttering and confusing the user more than actually showing them something of interest. I often sometimes talk to these, but I often refer to these as kind of like elbows. I mean, is there much value to having this elbow node between these two nodes? I would argue there isn't, and in fact, it's kind of hiding a lot of the context of this data set. So my final view of this data set would actually be combining all of those transaction nodes into a single link, and that is a model choice rather than any sort of interactive choice. I think that an end user likely wouldn't really want to see this view because it really kind of doesn't really show you what they're looking to see. So here's my final view of this data set, and you'd be surprised maybe to think this is the same data set, but that's all those same transactions, but this time the model is grouping them together as links. So now there's no elbows, you know, we have people and we have the merchants they spend money with, which is quite nice. So there, see, that person is going to all these places, this person is going to all these places, and so on and so forth. And you can spot here as well that the link widths are updated to match the spending amounts that people are making against those merchants. So that's an example where the property is being put onto the transaction, onto the link there, and is shown in an interesting way. So I can see that this person is spending more money than, say, this person with these other vendors here, which is maybe of interest to me. So this leads me directly into sort of my visual cornerstones that I like to talk about. So the first cornerstone I have is certainly that your visualization should be intuitive. And this is, again, all about building trust with your end users regarding what they're looking at in their data set. So I think I've made some good first steps towards how this data set is intuitive. We have icons, which are always really, really important to giving a quick view of exactly how the data is formed. So we see people and we see merchants. I can maybe add more details on the links, maybe have some sort of date time, or use the KeyLines time bar to give an idea that those links are actually points in time because they are transactions. But really, the idea here is that your chart should be intuitive when end users look at it and start to work with it. I have 3 other cornerstones that I like to just present quickly, and I'd like to hand over to Joe shortly to go into a little bit more detail, because I do think this feeds directly also into the interactive as well, interactive elements of your user experience. So that's intuitive at the top there, and I think that is definitely first. You do want your interaction and your application to be intuitive to your end users. And following the same sort of thought process that I've shown you for this data set today, I think that's really important to speak to your end users and understand exactly what they want to get from your data source. I'd like to just talk a little bit about consistency as well. I think of consistency as making sure that your application is both internally consistent and externally consistent. So internally means that the same actions that you apply to your data set, or the same sort of visual styling you apply to your data set, should be consistent throughout the whole of your application. So there's no reason why a certain interaction should result in a different event, depending on how you're using it. Maybe some sort of smart logic that actually confuses your end users. But when I talk about external consistency, I think about how your application is likely to just be one of many applications that people use in their day-to-day work. It's easy to maybe think that you hope that your application will replace a complete workflow, but in the real world, it's unlikely to be a kind of one-stop shop for absolutely everything your end users need. They're always going to be going to websites or other sort of data sources to really corroborate what they see. So by external consistency, I mean think about the other applications that your end users are using, and try and fit in with the sort of good design choices that those applications make. One obvious one to me is Google Maps, for example. Everyone uses Google Maps or something similar, and the sort of panning around and zooming in and out, which actually is quite well aligned with what KeyLines does with our charts. I think that sort of experience is the same sort of experience you want to kind of replicate in your application. You don't want some sort of esoteric interaction event that doesn't really match with maybe Google Maps or some other alternative application, if that's what your users use in their day-to-day work. Now, my final 2 cornerstones here directly feed into what Joe is going to be talking about shortly, so I won't steal his thunder. But these are really down to interaction events, and really I want to stress how important it is to build up that trust between your end users and the data that they're working with. So reversible means that we can always go back, we can always revert what we've done. I used to work with some analysts in a previous role using graph visualization, and the tooling they were using, which wasn't KeyLines, they actually like to move nodes around the screen and put them into certain locations. But if they clicked the wrong button, those locations were lost, and they were lost forever. And that was an extremely untrustworthy sort of interaction or experience with the application, and really caused contempt towards the application. So reversibility is really, really important, and KeyLines can really help you add that into your application. And then finally, I'm not going to go into the details of traceability because Joe will cover that nicely in a second, but traceability is also really important. So these are my kind of visual model cornerstones. I think they fit directly into the data modeling decisions you're making as well. But I'd like to hand over now to Joe to give you an idea of how your applications can really fit these cornerstones well.
Okay, thanks, Christian. I'm going to carry on the story now, and yeah, there'll be a lot of overlap between what Christian's been talking about and what I'm going to talk about, because of course in data visualization everything's quite closely connected, the visual side, the interaction side, and even the modeling side, where we're all kind of very much in the same area, but I'll be following on some very similar ideas. So what I want to talk about really is how we don't talk very much about how charts can be quite scary. Unless you're an expert in graph theory or data visualization, for users, looking at a chart can be quite a scary experience. If we look at the chart on the right-hand side of the screen here, it's just a clump of nodes. In fact, some of Christian's earlier screens, there's lots of nodes, lots of links. It's very hard to determine what's going on. It's very easy to visually overload users, and that's one of the most common pitfalls, mistakes I see in a lot of visualization. It's that there's just so much on screen and users can't parse it, they can't navigate it. And actually graphs can be quite unintuitive as a user interface. It's quite hard to know what to do, especially when presented with a lot of information. So I'm going to be focusing on something that Christian focused on as well, something we talk a lot about here at Cambridge Intelligence, which is reducing clutter. That's all about taking information away from the user, actually, and that GIF on the right hand side shows how we condense a very large complex chart down into just a small handful of nodes, which is much easier for the user.
There are three major techniques which I'm going to talk you through, which we use to reduce clutter and to help users out. One of them is to provide a big picture view and presentation of the data. One of them is to provide a more explorative approach to the data. And the third and final one is to allow users to slice their own part of the data, to slice the chart themselves and look at the components they're interested in. I'm going to walk you through some demos we have in our KeyLines SDK site. This is a site which we make available to KeyLines users. It's full of documentation and demos and good advice. And I'm going to look at some of these demos and pick out some good and maybe some not quite so good UX, but really to try and back up these ideas. So the first thing we're going to look at is the big picture approach. A means to give a user a high-level summary of your chart, which won't overwhelm and intimidate them. So now we're looking at the KeyLines SDK site. The chart you should be able to see here. It's the one we saw in the GIF on the other slide, and it's just a big mess of nodes and links, and it's really hard to discern anything of any interest at all here. This data set is actually showing suspected terrorists and connections between them. If I zoom right into the chart, you might be able to see here's a few suspected terrorists, and we can see their names, their countries of origin, and links to other terrorists who they are believed to have been in touch with. But without looking down on the chart or drilling on a few nodes, it's really hard to get anything useful. So a technique I'm going to use is similar to what Christian did actually. It's what we call combining nodes, and KeyLines provides useful APIs to do this. And this allows you to take nodes with common properties and to combine them together into a single node. I'm going to press this button over on the right hand side of the screen here, and that's going to combine all the suspects by their country of origin. I'm not sure how it's going to come across in the webinar view for you guys, but on my screen, I'm going to see a beautiful smooth animation, which means everything is nice and traceable, and I can really follow what's actually happening on the screen. And you'll see their nodes will kind of move in towards each other. They'll combine quite smoothly, hopefully, and then read out on the screen. And straight away, just by reducing all the clutter of just showing the nodes individually, you can actually straight away start to gain some insight from this chart. The larger Afghanistan node here suggests that there are more suspects in Afghanistan, and France also seems to be an area where there are lots of suspected terrorists. But also looking at the connectedness of some of the nodes. So Morocco down here is a sort of one of the bigger nodes, probably in the top half in terms of number of suspects, but there's actually only about 4 links to other nodes in the chart. So just by reducing the amount of stuff on the screen, we can really make it easier for users to understand what's going on. Now you may have noticed that when I hovered over Afghanistan, the node opened up, and this is a really important part of what combos can do for you in KeyLines, and it's part of what makes things traceable and reversible as well. No information has been lost. So if in your backend data model you were to combine nodes by country, you would see a nice high-level view. It would be quite hard to kind of have a look at Afghanistan. If I zoom in here, you can see all the original nodes we saw before, and we can see how nodes and different suspects communicate and interact with each other. But we still have a view on the wider world and what's going on outside. It's very important not to hide information away and make sure that users have an ability to drill down and get more access. What we can also do is if I zoom in and click on a few nodes inside Afghanistan, you should see that, where's a nice example? There's a okay one there, here we go. So here we're doing what we call revealing links, and this draws any links from one combo node to another combo node. So we can see that this particular suspect in Afghanistan has a lot of connections out to France and just a few connections down to Algeria there. And that really lets us kind of analyze and drill down and investigate particular stories and see what's going on in the chart. The other thing we do here, of course, is we draw certain nodes into the foreground and push some nodes into the background. This really helps us focus on the piece of information that the user is looking at. So when the user selects this particular node here, we only foreground, we emphasize information which is relevant to that particular node. And again, coming back to the idea of reversibility, we can always click on this button here to uncombine nodes, which will bring us back to the clutter we had before, which there's maybe some benefit in the user to going back to this view, particularly if they've got a sense of how the data set comes together. They can still now zoom in on particular nodes and clusters, and we still have some foregrounding capabilities, so I can click on a particular node and see how that impacts the rest of the data set. Okay, so that's the first example. And just to recap very briefly, we've talked about how we can use KeyLines APIs to group nodes in the front end in the client and maybe even empower the user to do this. We've talked about the importance of drill down interactions, the ability to open combos and have a look at what's inside, the ability to reveal links and see how nodes inside combos interact with the rest of the chart. And we've also seen the importance of foregrounding to focus and highlight particular things that the user wants to look at. Oops. Okay, so next we're going to take a look at the more exploratory approach to exploring the data set. This is a technique which is often used by investigators and police and fraud investigators looking at very large data sets where there's too much information to possibly see. We're going to look at our product manager's favorite movie and use that as a model to explore a large data set. So coming back to the SDK site, here we have a demo which shows this shows how we integrate with a Neo4j database, but what I'm interested in here is how we can take a very large data set such as the world of movies and actors, and how we can expose the user a very small slice of it and then explore it outwards according to the investigation. So this demo here shows The Matrix, popular '99 movie, and all the some of the major actors who featured in it. There are, I'm fairly sure, more actors than you can see on the screen, but these are some of the major ones we've captured for our particular data set. And you might notice that there's a very restrained use of color here. So all nodes are black and all links are gray. Because we only have two types of node, we can use different icons to distinguish movies and actors quite clearly. And we don't need to confuse or bedazzle the user with lots of different colors on screen. So what we can do is we can explore this chart node by node and kind of find connections as we go by looking at certain trends. So if I draw your attention to Lawrence Fishburne here on the right, you'll see a green plus icon. This is a reasonably intuitive way to tell the user that they can expand this node and pull in more data related to the movies that Lawrence Fishburne acted in. So if I double click on the node, we will expand it. And that pulls in two more movies into our view. Now you may have noticed two things which happened when I expanded those nodes apart from the data coming in. First of all, any existing nodes in the chart weren't moved. This makes the change we made traceable. We're not confusing the user by moving nodes around too much. The second thing we've done is we've moved the camera, we've zoomed and panned a little bit so that we can more clearly see the new nodes that have entered the chart. I suppose the third thing we've done as well is to highlight the new nodes in a nice pink color. So that we can see what's relevant, we can see the changes, it becomes fairly intuitive what just happened. So if I expand a few more movies out and I bring more actors and links and nodes into the screen, you'll see each time that the chart moves and zooms a little bit to show new information. And what's particularly nice about this model is that users can develop the chart in their own way. So rather than being overwhelmed with a whole glut of or cluster or hairball of information, they can expand the chart bit by bit and they're always in control, they know what's going on. Sooner or later, of course, you're bound to fill the chart with a few too many nodes, and then things get a little bit cluttered and you start to lose structure and it kind of gets hard to know what's going on. We have a cross link here from Carry On Moss down to Lambert Wilson, whoever he is. So what we might want to do is we might want to run a layout at any time. So using these buttons on the right hand side, I can just run my own layout. And then we know what's going on, and that's the thing that the user can do whenever they want, whenever they need to. By using animations, it makes sure that the changes are traceable, and it really keeps the user in control at all times. Okay, so that's the explorative approach to exploring large data sets. We expand nodes on demand and give the user control of when that happens. That helps the user build a mental model of the data set and keeps them in control at all times. We're very careful with how we use animation and how we move things around on the screen so as not to overwhelm or confuse the user. And we have very simple color choices, which again help stop to overwhelm or confuse users. Finally, I want to talk a little bit about user slicing. So this is a technique which lets the user take a data set and, using some predetermined analysis, just take a particular cluster or portion or a component from that chart and just look at that in isolation. So I'll pop back to the SDK site. And here you see our impact analysis demo. And well, you may have two thoughts on this as you see it straight away. First of all, it's quite a tightly connected cluster of nodes. It's hard to get any particular insight at it from a glance. The second thing you might notice is there's quite a lot of colors going on, which are potentially a little bit overwhelming. I actually think the color choice in this demo is quite good, and I'll get onto why I think that is a little bit later. But first, let's give you a bit of context. This data set shows components in an IT network, IT infrastructure. So if I zoom in a little bit, we should start seeing things like servers and virtual hosts and switches, and there's a few hard disks floating around as well. So this helps users look at an IT network and try to identify key points of risk and failover to understand where certain components, if they were to go wrong, what the consequences might be. Now, it's very hard to look at a chart like this and get any particular insight from it. We can help the user out with a few little things. There's this little thing on the right hand side here which says show impact analysis. That will resize any nodes which we've determined to have a high number of impact, i.e. if those nodes were to fail, then a lot of other nodes and the dependency nodes would also fall over. So things like disk drives have been highlighted here, and there's a few switches in the middle here. The larger nodes are the ones that are at risk, but even by running that analysis, it's still quite hard to kind of get a feel of the overall chart and perhaps the consequences. I mean, if this SAN unit was to die, it's very hard to know what would actually happen. There's a few things we can do in interaction and visual design to make that easier for the user. The first things we can do is, as we hover over the node, you may be able to see there, we highlight any dependent nodes with a red halo. That means the user can explore the chart and get a better sense of any particular node, what is the size of the network that's going to be affected by it. That's a really quick, useful preview technique, but what I'm really interested in this demo is how I can click on a particular node, then we fade away any of the node in the chart which isn't part of that component or that dependency graph. Straight away, I've removed quite a lot of clutter and it's completely in the user's control, and I can unclick at any time to bring back the rest of the chart. It's reversible, it's consistent, it's super easy to make my way around, and it's hard to get too confused by this. Another really nice thing we can do in this particular demo is we can use layouts as our friend. And if I click on the radial layout on the right hand side here, this will rearrange the chart and put the top of the dependency chain right in the middle, and show around the edge. It will show all the different things which might be affected. What's also nice about this is the color design starts to make a little bit more sense now. You can see that different types of hardware or software or different dependencies are different colors. So you can look at those at a glance and you see that different colors form almost layers around that central node, and you can really see how the network fans out and how things at the end are affected by things really deep in the core of the network. Because we're talking about things in IT infrastructure which may be quite hard or subtle to determine, so if you look at some of the icon design here, the difference between the server and the monitor, well, they're both just sort of boxes, aren't they? And even the tree is quite difficult. And when you zoom out a little bit further, it gets very hard to tell the difference between those two different components. So that's where the color design again starts to become a bit more useful. By coloring different types of nodes, different colors, it becomes easier to determine which kind of node is which at a glance. The colors balance quite nicely. They're not too contrasting. They're colorful and cheery, which is quite nice in our showcase demos, but most importantly, they're contrasting, they stand out, and they don't clash. You might also notice that the links have quite neutral grey colours, so they don't interfere or get in the way too much. Okay. So that's user slicing. This is a technique which we can use to give user control over which piece of the chart they want to look at, to isolate interesting subcomponents, and just to explore those networks in isolation. We give a nice preview effect through hovering, which means the user can look at consequences of their actions without having to kind of see the whole chart move and dance around. We use animation again to make sure the changes are traceable, and the color palette is complementary and not too clashing and not too strong. So I'm going to have a little go at bringing together everything that Christian and I have talked about through this webinar and give you some of our top tips about how to avoid wrecking your own data visualization. The first thing to talk about is, as Christian said, design the data model carefully. It's a really important cornerstone of everything you will do in your chart. It's good to experiment, it's good to take a bit of time, it's good to look at a few different things, but put some effort into making sure that your nodes and links are correct, that you're linking things according to the right reasons. It's really important to consider the user's journey through the chart. So think about the kind of things the user wants to do. Think about the expertise your user has. Think about what kind of analysis they might want to do. Do they want to be able to do their own slicing and so take a few nodes and just hide everything else? Do they want to be able to expand the chart and look through a data set from a particular starting point? Maybe they know one suspect they want to investigate and they want to explore out from there. Think about how you can reduce clutter. I think this is the single most valuable lesson from this webinar actually, and it's something I see a lot. Just try not to overwhelm users, reduce the number of nodes and links as best you can, whether you do it through analysis techniques in the front end or data techniques in the back end. Of course, by reducing clutter, you potentially remove information, so make sure you provide drill down options to users, make sure they can get at more information, make sure they can investigate. And data visualization is quite a inherently playful thing, so make sure they can play and explore, and there's benefit in clicking on and moving nodes around as well. I think that's quite an important thing. As Christian says, be consistent, be traceable, be reversible, and be intuitive. Not always easy to do all those things, but think about them as you're designing your visual interaction and data models. And finally, make sure to use color sensibly. We see lots of clashing colors from our customers and various people we speak to. It's not easy to pick the right colors out, but it's worth spending a bit of time on. Think about it and just try and avoid things which are too bright or too clashing. Okay, that's all for me. I'm going to hand back to Dan.
Very good. Well, thank you very much to Christian and Joe for a great presentation. I hope everyone listening found it useful and you learned one or two things that you hadn't thought of before. I'm going to wrap up now with the Q&A. So if you have any questions, some people sent questions in advance, which is very helpful. We appreciate it, and we will get onto those first. But if you have any questions on what you've seen today, now is the time to send it in. Use the question and answer tab on the GoToWebinar control panel, and we will put those questions to Joe and Christian, our graph UX experts, and see what they have to say. So while you think of those, just a reminder, we have mentioned KeyLines a lot in that webinar, and I know not everyone on the call is familiar with KeyLines. So without wanting to do too much of a sales pitch, that is what we do here at Cambridge Intelligence. We make a KeyLines SDK. It is a tool for building all of the demonstrations and examples you've seen today. It's what was used. It gives you that control so that you can get exactly the user experience you want to provide and embed it into your own applications. So do get in touch if you're interested in finding out more about it. Okay, so it's time for the questions, and we'll start with the questions that were asked beforehand. So the first question, and I'm going to pick on Joe or Christian to answer all of these. So let's go for Joe first of all. I'll pick on you. How can we ensure the legibility of labels, especially at low zoom level? Are there options beyond truncating?
Yeah, that's a really interesting area. I have a few personal hang-ups about label design. So something I see and something we do by default in KeyLines is we give labels a semi-transparent background, which is really helpful when nodes happen to overlap each other somehow. But at low zoom levels in particular, it gets very hard to actually read what labels might say. So I'd encourage using no background on labels. If it's just text against the chart background, it becomes much easier to read. At low zoom levels, the background and text sort of start to clip because there aren't enough pixels to draw both. So I think just keep text labels clean. You may want to consider drill downs. So if you hover over a node, perhaps you want to display a tooltip to show what the node label is. But ultimately, you're kind of fighting physics. The further out you zoom, the smaller the nodes, the smaller labels can possibly be. So think about whether you really need labels. Can icons help you out more? Can you take smaller slices of the chart to show things, show fewer things at one time? Then labels becomes more readable and less problematic.
Very good. Let's pick on Christian this time around. So you can see it there on the screen. Any advice or tips for exploring larger networks with a lot of child nodes? How can we avoid overloading users with a starburst effect? And how can we keep the user focused? Christian, do you want to take that?
Yeah, of course. So yeah, I get this question a fair bit, and there's a number of great ways to work with this sort of exploration and overloading with explored data issue. So first up, I think one great tip for exploring larger networks with lots of child nodes is certainly to maybe have some sort of cap to say, if somebody is double clicking or expanding a node and bringing back a lot of data from the database, it's always worth it just to give them a heads up and say, FYI, you're about to bring back, let's say tens of thousands of nodes. And you're not really going to find that much benefit from putting just those child nodes onto the network. So I think a cap like that, and just maybe just a way of saying, hey, are you sure you want to do this? If you do, be like double clicker aware, be aware. But even maybe having some sort of use of our graph engine to say, well, maybe let's find the most well-connected nodes that you're looking to expand and only show those ones onto the screen. Now, the starburst effect is something that we come up against a lot, and that really is the case of having too many child nodes from a node. And I have quite the opinionated view that child nodes in that regard are a little unnecessary. I don't see that you get that much value from seeing all those child nodes on the screen over then just having maybe a single node or some sort of indication that there are a certain number of child nodes. So I have two approaches to working with this. My first option is to provide an end user with a button that says always hide child nodes. You want to have some sort of visual indication that they exist, but really there's no need to be adding those into the mix for running layouts and trying to work out where they should be, because they're just going to overload everyone. The second option for those child nodes is a little more experimental, but I think it works really well if you know what you're doing, and that is to group those using combos. So if you have just child nodes and they're not linked to anything else, why not group them together into a combo, put a little indication in the top right with our glyphs to say, hey, there are X number or N number of nodes contained inside this node. And then, they can always open that up if they want to look at it using open combos. But in reality, again, because they're child nodes, they're not going to connect to anything apart from that original node. So I think that's a much better way of looking at that data. And as I say, it's a little experimental. It's not that well adopted in the space, but using KeyLines, it's quite reasonable to do it. And I do think that adds a lot of usability to your large graphs with lots of child nodes and starbursts. Finally, how do we keep the user focused? That's a great question. I wish I knew the answer. Maybe less coffee or maybe more coffee, I'm not sure. But in terms of keeping them focused, I think minimizing the amount of interactivity or the amount of boxes on the left and right around the chart is always good. It's always good to have restraint in terms of what you're exposing to your end users. And maybe today we give you an idea that there's a lot of different choices, a lot of creativity in how you build your applications. And I think less is often more.
Yeah, I would agree with that. Thanks, Christian. So a question before the webinar, and I think someone on the webinar has just asked the same question as well. So what are the best color palettes for graph visualization? I'm sure that's slightly subjective, but I'll hand that over to Joe.
I'm glad you asked me that, Dan. That's quite easy, really. It's electric blue on pink. It's really hard. It is subjective, and it depends on what you're trying to do in your chart, right? And how many different colors you may possibly need. I advise trying to reduce the amount of colors you need, as we saw in two of those examples. One worked very well with just black nodes and gray links. The other one worked very well with lots of different colors. I think I quite like pastel shades, but not too pale. Nothing too strong or too bright or too luminous. So avoid your basic primary colors. Muted shades tend to be a little bit clearer. I think links you should probably keep as muted as you can. There's loads of use cases where you need colorful links and colored information in links, but if you can get away with it, fairly pale links so that they don't obscure nodes and obscure detail in the chart. But there's as many answers to that question as there are colors. But I advise keep it minimal, keep it simple, and keep it muted.
Yeah, and just to add to that, there are lots of tools out there for picking color palettes online available. Color Brewer is one we use a lot, I know of. And there's plenty others out there, and I think tools that help you pick a good color scheme for a website are equally good at helping you pick a good color scheme for a graph is. So use what's out there. We have a blog article as well on that, I think, and I'm going to try and make sure we send you a link to that with the follow-up email that does talk a little bit about color as well.
I would also say if you have access to the SDK site, the different demos that are on there show loads of different ideas for color palettes, just sort of almost accidentally. There's a really great range of things. Some you'll like, some you won't like. Worth a look.
There we go. Okay, so last question on the screen there. There's lots more coming in there, which is great. Keep them coming. Our application provides two views of the graph, one high level, the other more detailed. What is the best way to let users switch between these views? Christian, I'll hand that one over to you.
Great, thanks. In terms of best way, I'm not really sure we can ever come up with the best way. But this sort of two views thing is quite common, and I think it is, when used well, it is a good approach to showing kind of two ways of data. I would say that trying to have more than two, maybe 3, 4, 5, it does start to get too complicated. And again, going back to my previous point, you do want to be restrained in having different views. But two views, I think, is a great number for number of views. And it also is something that KeyLines does quite well, in that you can quickly change between different views. You can do changes to the model on the fly right there in the browser. So what I've seen work quite well is just having a nice, simple toggle. Well named, it needs to be a good distinction between the two views. So I've worked with a company in the past who had a data view versus a person view. And just hearing those words, you kind of get an idea what it's going to be showing you next. So yeah, I think a toggle is fine, but I would say stick to the two views. You don't want to be overloading your end users with lots of different ways of looking at the same data.
Very good. Next question, I might stay with you on this, Christian, because I know that you've got a lot of experience with integrations with other systems. There are a couple of questions about and this relates to what you were talking about with the data modeling side as well. So one question, does this work with RDF graphs? And another is, do you interface with OrientDB? So maybe you could just say a little bit about any limitations on the back end and how the two play together.
Yeah, of course. So at its core, KeyLines is a generic toolkit in that it can work with any sort of backend. So whether that's JSON, CSV, it can all be converted quite easily to be used by KeyLines. So we don't lock you into any particular database. We've had an OrientDB demo for quite a while, and it shows you exactly how you can use OrientDB as a data source for KeyLines, and that is on our SDK site. We've actually just today released our first official RDF demo on the SDK site. We've always supported RDF, but it is something that we see less from our customers. But we have a Stardug integration that's been deployed today on our site, so you can take a look at that today. We also, for example, support Amazon Neptune, and the demo on our site uses Gremlin, so it uses a property graph model, but Neptune itself can also be an RDF source. So yeah, in summary, pretty much any sort of data, as long as it has some sort of collected element, can be used with KeyLines. And I see customers who are the most successful using KeyLines actually combine data from different sources. So it doesn't matter if you're just RDF or property graphs. You can bring together data from multiple sources, and that's when you get the most insights from your data.
Very good. So we're coming towards the end. I think we said 45 minutes. So we'll carry on. There's a couple more questions and ask those. If you have to leave, though, thank you very much for your time. Appreciate you joining us. A couple more questions that have come in. One of them, I'll ask Joe this one. Is there a restriction on how many nodes the visual tool can scale to?
Yes and no. I mean, technically, not really. KeyLines can render, it can render 10,000 nodes and links very quickly. Some things like layouts can start taking a bit of time, inevitably, because there's a lot of calculations to be doing when you're talking about networks that big. But the other side of that coin is by the time the computer starts to struggle to render things, the human's not going to be able to make sense of the chart. So again, with a view on reducing clutter, try and keep as few nodes as you can get away with on the chart. Think about how you can combine things, how you can merge things, how you can filter the data set, and how you can give users slicing abilities so that you don't have to render 10,000 nodes on the screen, because really that amount of data is really, really hard to parse for a human.
Yeah, I would second that. The visual overload tends to happen much sooner than the CPU overload. Yeah, so think about that. This is a bit of a philosophical question that I'm going to throw Christian's way. What are the cases in the real world that people use graphs as a tool? The questioner says, for me, a graph is more of a visual display and not an exploratory tool. So what's the function of a graph, Christian? I don't know if you have any views on that. Where does a visualization become an interaction, and what should graphs be used for?
Wow, what a question.
Sorry about that.
So, I mean, when you say for you that graph is more of a visual display than an exploratory tool, I would suggest that perhaps you haven't seen the right sort of graph applications. I think a lot of our customers, we have over 200 customers worldwide, and a lot of them have really, really compelling exploratory tooling as they work with graphs in that application. So, the things that Joe talked about today and I touched upon, I think those can really lead towards a very rich exploratory environment. But the way I think of graph is certainly that, a lot of our customers, in fact, all of our customers have some sort of secret source in the data sets that they have, and the way they work with those data sets and the analytics they run against those data sets. But often it's the case that those are a little bit of a black box to their end users. So they can maybe see a spreadsheet and say, these are the results you needed. But more often than not, again, there is a connected element to what they're producing and what they're generating with those backend databases. So I feel like Graph really steps in at the last piece to really display the results of that hard work, and that's a really exciting place for us to be in, because we can really help bring that to life with Graph. So as I've alluded, that's a really big question. Happy to take that offline, but hopefully that gives you an idea of where I see the use of Graph in this space.
Sounds good to me. Okay, and I think we've got time for one more question, which is, and I'll ask Joe this one, what is a good way to visualize information that's stored within the links without creating a lot of clutter?
There's a few ways you can do that. So You can put, in KeyLines at least, you can put glyphs on links and labels on links. You've actually got space for a label at both ends of the link and in the middle. That can start getting cluttered if you're doing a lot of that, but glyphs in particular, you can show numbers on links quite effectively, so maybe the size of transactions. You can also imply a lot of information through links, so using link thickness, which Christian showed earlier, is a really good way to say that rather than having several links between things or have a number on the link, if one link is thicker than another, that implies a stronger connection, which maybe implies more value in the transaction between those two particular nodes. Simple, fairly crude visual things like that can actually be very effective to shortcuts in the information you want to display through numbers or through text.
Yeah, I think definitely there are some nice visual things you can do, but also in a lot of cases I've seen people have a lot of textual information, and generally if you have a lot of text, it probably doesn't make sense to throw it all on the board initially, because it will just overwhelm. And that's where I would look at things like interactions, hover over a link or click on the link, and then the tooltip comes up with that extra data, rather than trying to put it on, because if you put all that text on your chart, then you've just created a screen full of text, which probably defeats the object.
That's what a drill down's for.
Yeah, okay, I think we're out of questions. So thank you very much to everyone who's asked questions. Thanks to all of you who are still on the line, and for your attention. And finally, a big thank you to Christian and Joe for a great presentation. With that, we'll end it. We'll send the recording out to you soon, along with a link to the blog, and look forward to seeing you at another KeyLines webinar very soon. Thanks very much. Goodbye.